Hello students, today's class is non-coherent receivers. This is the last topic in your fourth unit. So in the previous lectures we discussed about various digital modulation techniques and its corresponding bit error rate, performance of signal space analysis. So in this lecture we are going to discuss about non-coherent receivers. So non-coherent receivers can be done by two techniques. One is without phase information we can demodulate the signal, and the next method is there is no need of a synchronization to get the demodulated signal. So these two techniques we have already discussed in the DPSK, that is differential phase shift keying method. So here I have given an example for non-coherent receivers to recover the original signal. So I hope you remember the operation of the DPSK modulation. So this is the generation block. It consists of encoder, time delay unit, product modulator, summer, and finally we can generate DPSK signal. So the basic operation is input signals bit streams are given to the encoder. This produces the non-return to zero bipolar bit stream. Then the output of encoder is given to the time delay unit. So here one time period delay is introduced for every bit. Then the outcome of this is given as an input for product modulator, and here we are applying carrier signal. So here we are simply applying the carrier frequency, but we didn't consider about phase information. Then it is a summer block. From here we can able to produce a DPSK signal. It may be plus or minus AC cos 2 pi FCT. So without giving the knowledge of phase details, we can generate the phase component of the DPSK signal. So that is the basic principle. Okay, let us consider this example. So this is binary data which is represented as BK. Here we are giving this input as 00100100111. So the differentially phase shift keying output from the encoder, which is written as D of k. So for D of k, first the signal is 0, then 1 unit of delay is introduced for every bit. So after one delay it is going to be 1, then it is 0, then again 1, 1, 0, 1, 1 and 1. Then we have to identify what is the phase of DPSK. To obtain this DK, I have given the formula in DPSK. Please refer that formula. Then phase of DPSK, you have to compare these binary data on the encoded data value. If both outcome is 0, then the phase shift is considered as pi, and if they are different, then you have to give the phase value as 0. So here both are same, so phi. Here it is different, 0, and here it is different, 0, same, pi. Here different, 0, 0, and here it is same, pi. So this is how we are finding the phase of DPSK. Similarly, the delayed unit TK minus 1, which is equivalent to, so this is our DK. For DK we are introducing 1 unit time delay. So for this 0 we don't know the previous output. So let us assume this, that value was 1. Then the next, for this one, the next bit will be 0, previous value. For this one, this is the previous value 0. Similarly, for this one, the previous value will be 1, and for 0, this is 1. In this way, you have to write the outcome. Then the phase dk minus 1. As I said earlier, if it is 1, then 0. 0 means pi. That is, if the outcome is 1 or plus 1, there is no phase shift. If it is 0, then the phase shift is considered as 180 degree. Then we have to compare the output. Comparing output, for 0, there is no phase shift, so minus. Here it is 180 degree phase shift, minus. Similarly, here it is 1 0, so there is a change, so plus. Here there is no change, 0 0, so minus. Here it is 1 and 0, so there is a difference, there is no change. And here it is 1 and 0, it is a difference is there, so it is plus. So here also same, so minus. Here also this 1 and 0 difference, so pi introduced. So in this way we can expand the signs of the outcome. Then the detected output is equal to, you have to compare the binary data with the detector value. So this is the comparison output generated by this device. So detection output is equivalent to comparison output. If it is minus, there is a data is 0, minus 0, plus means 1, minus minus, so 0 0 1, 0 0 0 1 1. Now we have to check this detected output with the binary data. So what we have obtained, 0 0 1 0 0 1 0 0 1 1. So the same thing is recovered in the output side also. So in this way we can generate DPSK signal. Then detection. So this is also we have already discussed. In the detection, one integrator is introduced, delay unit is there. So the integrator outcome is going to be verified in the decision device. If the symbol of I is greater than 0, then the outcome is considered as 1 for positive values. If the symbol is 0 or I is less than 0, then we consider this value as 0. So greater than 0 now, we are deciding the outcome as 1 for a positive value. If it is less than 0, it is considered as there is no phase shift, 0 value. So bandwidth already we have obtained. We know that it is equivalent to FB. Advantages, there is no need of carrier at the receiver side. From the circuits itself, with help of this decision device and integrator, we are identifying the phase. Disadvantage, probability of error more, noise interference is also more, because we are not aware of phase angle or phase shift, because it is a non-coherent detector. We are not using the carrier frequency for recovery. Okay, thank you.